Last week the game used to render like this on one of my older laptops, and now it renders like this. After the past few weeks of making the game look better, turns out I also made it slower, and this week I had no real choice but to try and figure out what the cause of that problem was, and turns out there were quite a few. And now on these older laptops the frame rate is a bit better. This is a procedurally generated game about exploration and discovery in a high fantasy world. You discover things, collect items, kill monsters, and I'm trying to make the game performance so you can actually play it well. Imagine that. So most of this week was just spent crawling through GPU profilers and trying to figure out my stupid mistakes. Such as, if we consult this GPU profile from last week, we can see we're running at about 19 milliseconds, and really we need to be hitting at about 16 to get 60 frames a second. And that brings me to my first crusty error. This thing. We can see we're spending about half of our time on the vertex shader. I have a set color palette to choose from with 255 values, so each entry fits into 8 bits. Now, as part of the voxel definitions, I used to pass floats in for the vertex definition to give sample coordinates to get the UV values from the texture. However, recently I switched to determining these values in the vertex shader by sampling this big array with 256 values in it, which was generated offline by this shoddy ChatGPT script. Now, what I thought the shader would do is notice that the array is a constant, so it's never going to change, and instead just create the values up front when the shader was compiled. And on some platforms it did, and on others, see, the ones that were getting the really bad performance were actually not inlining it at all. Instead creating this entire array in place for each vertex, every single frame, all 256 values. Even more surprising was that one of the culprits for this was macOS and Metal. I just didn't notice it because apparently Apple Silicon outperforms Intel GPUs and can still hit 60 frames a second. Who knew? Even with this ridiculous performance bottleneck. Honestly, it didn't even cross my mind that that might be a thing that would happen. Not even for a second did I think that that would not be inlined. So right now I've substituted it for calculating the text UV actually inline rather than creating the array, but this could obviously be improved. With that performance fixed, my render time drops down to 13.57 milliseconds, and the performance graph looks like this. That was the easiest fix, but there are still quite a few others. The next one this week is that I refactored basically the entire compositor pipeline. The old pipeline, I made a bunch of bad decisions because I didn't really know how to tell it to do certain things. My goal was just to get it working rather than actually performant. So I added a load of shader steps because I didn't really want to figure out how to do some of the depth buffer sharing or the proper testing. This was probably the biggest performance black hole of the entire week though, because I ended up with loads of textures, loads of short and unnecessary shaders, and just loads of awful performance as a result of it. So from looking at this GPU profile, I decided there must be a better way. And there was. By figuring out how to share depth buffers between passes, loads of the shader steps like this just became completely unnecessary. So I can just skip them entirely, killing off a nice chunk of unnecessary work and also reducing overdraw, which is something I'll tell you about later. And lads, I was also able to cut down my total texture usage from 12 to only 3. Which is fantastic. And simplifying the entire procedure will probably be the biggest performance gain of this week. So all in all, the time saved on the first one was about 8 milliseconds, which is a really decent amount. So the next thing is that I've pretty massively improved the speed of the line draw algorithm. I've managed to make it about twice as fast. The first thing I do now is only compute the lines on the inside of the mask. So this means that essentially the majority of the pixels can just get skipped. This does mean thinner lines because they're not on the outside anymore, but I can get around that another way. I also now check specifically for one of the pixels being 0 to mark out an edge, rather than just averaging them out. I can make a lot of assumptions because I know I'm only really drawing 0 or 1. I've also reduced the amount of sampling of the mask texture necessary by packing all of the values into a single texture. I just write the mask into the red, the distance into the blue, and this means I can cut my total texture samples by 5. So next thing was that I figured out that the background compositor that I had was actually really slowing down the entire thing. This was one of the first things I did on this channel. To animate things like the coin effects, I'm actually rendering them in 3D using an orthographic camera to a texture, and then drawing that texture onto the scene with a complete GUI. The problem I found from profiling is that even just the act of rendering and drawing a single one of them took about 10% of the GPU time. So this is a massive drain for not really much reward. I do obviously have plans to make the rendered effects more interesting, so I've kept the foreground one, which is where the coins are drawn to, but I have removed the background one because I wasn't really using it, and this saved me a good chunk of GPU source. So next thing now, I've reordered my render queues quite massively to help prevent something called overdraw. This is a slowdown where you end up computing pixels which end up not even contributing to the final image. So for example, I used to render the main scene like this, ocean first, then terrain, then trees. Now this might seem like the most obvious way to do it, but actually what I really want to do is render them front to back. Because look at all these pixels down here that don't even end up anywhere near the final image. I did actually know about this, but I made a massive oopsie in the code when I reordered my render queues. So I made it so that the water gets rendered first. So by rendering the trees first, then the terrain, the GPU pipeline will be able to consult the depth buffer and determine that these pixels on the terrain should not even be computed. And the same for the water underneath. So this does give a pretty big pixel shader optimization, and to be honest, this was actually totally my fault, because Ogre 3D would have done all this for me if not for me trying to be clever with the compositor. So I just had to make the point to manually reorder things in the compositor script so they were in the order that I wanted. Next thing, I've managed to set proper axis line bounding box for terrain chunks. That sounds complicated, but what this is essentially doing is just drawing a box around the mesh, and this allows an earlier CPU side algorithm to determine which things are actually visible to the camera so it can decide what to render or what not to render. Now the problem with this was that what I'd done when I was re-implementing the terrain voxelizer in C++ was obviously I just gave it the entire width and height of the map size because I wanted to debug it properly, and I wanted to make sure that the frustum culling wasn't getting in the way of me actually seeing my rendered mesh on the screen. So what that essentially meant was that no matter how you position the camera in the scene, every single piece of terrain was being submitted to the GPU to be rendered every single frame. There was no optimization whatsoever. So that is probably one of the biggest performance improvements I made this entire week. Next thing, I applied proper breadth first optimization for the GUI. That also sounds complicated. What does that mean? So basically, when rendering something like a button, the naive way to do that would be render the background, then render the text. Now that sounds good if you're only rendering the one button, but what happens if you've got 50 to render? That jumping between of rendering the background then rendering the text and keep switching is really going to hamper performance, because what you want to do is batch stuff up as much as possible. So if you instead said draw me 50 backgrounds and then draw me 50 labels, you only have 2 draw calls rather than 100. If you look at the old render pipeline from last week, it would draw a shape, draw some text and then start again, and do that for each widget, changing the pipeline and shader state as it goes. Right now though, the GUI is just a placeholder, as I hope you already knew, so cutting down the GUI drawing overhead is great. The GUI library I'm using does have the option to enable this sort of batching, and I just had to enable it. The downside is that if any of your widgets ever overlap each other, then things will just start to be drawn wrong because they're drawn in different orders. And the final thing on the performance front is that I finally experimented with Ogre's static and dynamic flags for meshes. So what this essentially does is when you go to create a mesh, you can just define it as static, and this will then make a lot of assumptions about the mesh, essentially that it's never going to move. Now what that means is that when you do things like frustum culling, which I mentioned earlier, you can just compute the values up front and then you never really have to change them. Now the reason I didn't set any of that stuff before for things like the terrain is because when you discover terrain it animates out of the ground. So I was well, it has to stay dynamic, doesn't it? But actually that wasn't really the case, because what you can do is you can say to Ogre, by the way, can you update this static object because I've repositioned it. Now obviously that's slow and you're not meant to do that every frame, but for a one-off it's fine. For a lot of things like the trees, the terrain, and a few other things, that is actually a really good idea. So that's everything I got done this week as far as optimization is concerned. There was quite a lot, and there were some really good improvements made there. If we were to compare the old GPU timeline to the new one, you can see how much of an improvement was actually made, and this is essentially to render exactly the same thing, so I am really happy with it. And just for you specifically, here's some other stuff I got done. I've done a bug fix with axis line bounding boxes for meshes. I noticed it was broken because moving around dungeons with the floor, it was just kind of disappearing at the wrong time, which again is frustum culling and says to me that something was just broken there. I actually double dipped the code for debugging it by adding a feature to my scene editor, which allowed me to select an object and then highlight the bounding box around it. So it's a nice editor tool, and it also kind of illuminated that there was actually a problem with it. And that was actually kind of funny because that did affect every single mesh in the game, not just the floor tiles. And you can see that with the editor here with stuff just kind of clipping in and out. I ensured the player never spawns in the walls in the dungeon. Really I just do this by adding a check around the spawn area during the MapGen, and I've also got a test which checks that. I fixed this weird Z order problem with the player special attack window, which had kind of been bugging me. I properly loaded all textures before gameplay to prevent bad frames. If you were to look at it in a video editor, you'd see it took a second before the textures properly loaded in. And finally, work is still continuing on my MapGen improvements. So I've now got the ability to define custom steps in the MapGen system using a scripting framework. So what that means is that gameplay mods can define their own additions to the MapGen procedure, and hopefully at some point we'll be able to actually call scripts that will be able to like interact with the MapGen data. Now the important thing about this is that it's running on a different thread. That is quite a big deal because I had to do like a lot of architecting stuff, but it's kind of like a work in progress. I'm like drip feeding this in because it's kind of boring, but it also needs to happen. So I've managed to get performance back to like where it should have been in about a week. Some of it was me just fixing mistakes from before, and some of it was just massive big-brained innovation. Most of my older laptops are now hitting the magic 60 frames a second mark, although now we're actually CPU banned. I've kind of come to realize that the next step really should be the Android port, because if I can't get decent performance out of a device like this, which is, you know, sort of old, then I kind of need to modify the gameplay around that sort of consideration. Now currently on iOS we are like fairly consistently hitting that magic 60 frames a second, but unfortunately if you're an Android fan, I mean they're kind of the Wild West as far as it goes for like fragmentation and just generally like software development. They're not really a good platform to develop for, especially when it comes to graphics programming. So I really do sort of want to get this done because I have to see how performant they are. We'll get back to gameplay sometime soon though, don't you worry.